This video is an introduction to integers. We'll be covering a basic introduction to what integers are. We'll be learning about integer interactions and multiples, divisibility and divisors, and then we'll go over a summary and I'll show you how to do some practice problems. So basically, integers are numbers that don't have decimals. They're like full numbers. Some examples are -4, 0, 5, and a big number like this. There are three main groups of integers. One of them is just 0, so it's just the number 0. The other one is all negative integers, which are less than 0. And the final group is all other integers, which are positive integers that are greater than 0. Now, some other names that you might hear when you're talking about integers are natural numbers. Now, natural numbers are the exact same thing as positive integers. It's just another way of saying that. Counting numbers, they're the same as natural numbers as well. So basically, we've got positive integers, natural numbers, counting numbers. They're all the same thing. And then whole numbers, they're almost the same thing. There's just a slight difference. Whole numbers are positive integers plus 0. So it's basically all non-negative integers. So that's basically the different types of integers. Now let's move on to some integer interactions and multiples. So basic integer operations. If you just add up two integers together, you'll get an integer at the end. And the same happens if you're subtracting or multiplying. The only exception to this is when you're dividing. All the other main properties hold. Because let's say you're doing 2 divided by 3. This doesn't have to be an integer, right? In fact, this isn't an integer. This is represented as 2/3, which is a fraction. And to see that it's not an integer, it's basically 0.666 forever. And that's obviously not a full number, right? It's not a whole number. Now, we could have some that do give us integers. We could have 4 divided by 2, which would be 2, which is an integer, so this does work. But the point is that it's not always the case, so division is an exception. Perfect powers, that's another thing that you might hear a lot about. You might have heard of something called a perfect square, and that falls under the category of perfect powers. A perfect power is defined as any integer raised to the power of an integer that is greater than or equal to 2. Okay, that's a perfect power. So let's say you have 3 to the power of 2. This is a perfect power. You can have 3 to the power of 8. That's also a perfect power because 3 is an integer and 8 and 2 are integers that are greater than or equal to 2. Now, what about 2 to the 1? Is this a perfect power? No, because 1 is not greater than or equal to 2. Now, let's talk about multiples. Multiples, this is one of the most important concepts, so make sure you understand this well. And you might already have some intuition for this. You've heard of multiplication, and it's pretty similar to that. A multiple of an integer is a product of that and any other integer. So, for example, let's say we've got 5, right? What is a multiple of 5? Well, you can do 5 times any other integer. Let's do 5 times 6. This gives us 30. So, 30 is a multiple of 5. And another example is 20. It's a multiple of 4 because it's 4 times 5. On the other hand, 21 is not a multiple of 4 since you can't multiply 4 with another integer to give you 21. Now do some practice over here. So pause the video, get the answers for this. So I hope that's enough time for you. If it isn't, just pause the video again, check now. But here are the solutions. So is 27 a multiple of 9? Well, 9 times 3 equals 27. So the answer is yes. What about 1001? Is that a multiple of 13? Well, you might not know this off the top of your head. But there is 1001 is a special number. It's actually equal to 7 times 11 times 13. Now, for this, the answer is no, since you can't do 4 times no number will give you 25. No integer will give you 25. And is 0 a multiple of 3? The answer is yes. 0 is actually a multiple of every single number because you can do any integer. So, any integer times 0 is equal to 0. So, 0 is a multiple of every integer. Now let's look at divisibility and divisors. So if a over b is an integer, then a is divisible by b. Okay, so that's written over here. A is divisible by b. An example is 40 divided by 8, which is 5. So 5 is an integer and 40 is divisible by 8. Because, so now we call 8 over here, 8 is a divisor of factor of 40. And we can also say that 8 divides 40 or 8 evenly divides 40. In general, if A is divisible by B, B divides A. So if you have A over B, if this is an integer, right, then that means A is divisible by B. So B becomes a divisor of A and it divides A. A proper divisor of an integer n is a positive divisor of n apart from itself. So it's basically, as long as it's not, let me give you an example. So 6, we know that 6, the divisor of 6, you can do 6 divided by 1, that will give you an integer. 6 divided by 2 will give you an integer, divided by 3 will give you an integer, and 6 divided by 6 will give you an integer. So all of these divide 6, so they're all divisors. Now 6 is not a proper divisor because it is 6. So it's all these other three, these are all the proper divisors. Now do some practice here. Just pause the video, give it an attempt on your own, and we'll see then. Okay, so is 15 a divisor of 3? No, it's not. It's actually the other way around. So the answer to this will be no. Right? 3 is a divisor of 15. One way to think about it is that multiples are like multiplication, so that gives you a bigger number normally. And divisors are like division, so it's a smaller number. Now, what about is 15 divisible by 5? Now, look, it's divisible by. So this is basically the same thing as does 5 divide 15? Yes, it does. Okay. And the answer is yes. Does 11 divide 99? 9 times 11 equals 99. So the answer for this is yes. Now, which is a proper divisor of 85? Right off the bat, we know it's not going to be D because that's not a proper divisor. It's 85 itself. And now it's out of these three. Are any of these divisors of 85? Well, what about 3? We can have 3 times 28. This gives us 84. Right? And if we do 3 times 29, this gives us 87. So 85 doesn't seem to be there. So it's not 3. What about 5? Well, 17 times 5 gives you 85. So B is the correct answer here because it's the, and 7, if you want to try it, 7, you can just do 7 times 12 equals 84. 7 times 13 equals 91. So if 85 were to be a multiple of 7, it would be somewhere between 12 and 13, and there are no integers between them. So 7 is not. Right? So C is wrong, and so the answer is B. Now, if you know, you might have noticed this, and most likely you did actually. Divisibility and divisors are the exact same as multiples, but just from a different perspective. So instead of saying A is a multiple of B, is a multiple of B, what did you say here? You said that A is Sorry, you said that A is divisible by B. Then you said that B divides A and B is a divisor of A. So it's all the same concept. Like you can just take two numbers. Let's say you take 12 and 2. 12 is a multiple of 2. 2 divides 12. 12 is divisible by 2. 2 is a divisor of 12. You can say all of those things. So there's an inherent connection um, between divisibility and divisors and multiples. So try to keep that in mind. Now let's look at some other rules over here. If a over b is an integer, let that integer be c. Then b times c equals a, right? Because a over b equals c. So you can multiply both sides by b, and you get a equals b times c. So b times c, which is right here, which means that a is a multiple of b. So that makes sense. And this is only true, of course, if b is not equal to 0. Because if b was 0, it would be a over 0, which is not defined. So that doesn't make sense. And so using this, if m is divisible by n, m is a multiple of n as long as n isn't 0. So this is basically like the connection between multiples and divisors. Now, we need to remember one thing. Negative integers can also be divisors or multiples. It's not just positive integers. Like negative 7 is a multiple of 1. It is a multiple of 1 because it's 1 times negative 7. Now, let's take another look here. Because over n is 0, these are some important things to keep in mind. Just do things, so it's not too much. Because 0 over n is 0, any integer except 0, like basically n should not be 0 because 0 over 0 is undefined, uh, right? Any number is a divisor of 0, and that comes from 0 is a multiple of any number, as long as the number isn't 0 itself. When finding the positive divisors of a positive integer n, and you can do the same thing for a negative n as well, it's a very similar method. Just check numbers between 0 and n. So let's look at the positive divisors of 15. 1 works, right? Now, can you do 15 over 2? No, that will give you 7.5, which isn't an integer. 3 works, and you can keep on trying the numbers, but 5 works, and then there's nothing else, and then it just ends at 15. For 24, there's 1, 2, 3, 4, 6, 8, 12, and then right at the end, 24. For the divisor of 6, this is where I'm starting over here. So there's 1, 2, 3, and 6. We actually went over this in a previous question. So that's good for that. Now there's one important concept to understand. If A is a divisor of B, so that means B over A is equal to some number, right? So this is equal to an integer. Let's call this integer, let's call it D since we're using C over here. So we know this. And we know that B is a divisor of C. So C over B is equal to some number E, right? Then A is a divisor of C. How can we figure that out? How do we know that's true? Well, we can multiply these two equations together, right? We can do B over A times C over B is equal to D times E. Now, D times E has to be an integer because it's the product of two integers. We learned that all the way over here, that multiplying two integers results in an integer. Now, if you look at this, we can cancel out the B's. So we get C over A equals DE. C over A means that A is a divisor of C because DE is an integer. So that's basically a proof for this. This is the exact same thing as saying if B is divisible by A and C is divisible by B, then C is divisible by A. And it's the same thing as saying this. Both of these just come from the connection between the definitions. So if it's a bit hard to wrap your head around, just look at it again, maybe go back to the previous slides and look for the examples there and the exact definitions. Now for some notation, if A is a divisor of B, we say A and then we put a bar over here and then we write B. Is this statement true or false? So is 6 a divisor of 8? The answer is no. 6 times no integer will give you 8. But what about this? 6 and then 18 over here. Is this true or false? So over here, since this isn't true, we just put a cross through there, like a small dash through there like this, to show that 6 is not a divisor of 8. And over here, on the other hand, this is true, so we just leave it like this because that means that it is true. Now take a look over here. Is 5 a divisor of 25? Yes, it is. 5 times 5 is 25. This would be true the other way, right? This would be true the other way. 4 does divide. It is a divisor of 168, but it's not the other way around. So this is false. Now, if 124 divides x, is 4 a divisor of x? Well, try to use this rule. Okay, the answer is going to be yes, right? Now, why is this true? 124 is a divisor of x. Now, isn't isn't 4 a divisor of 124? We know that, right? 4 times what number will it be? Let's see, it'll be 25 plus 6, so 31. 4 times 31 equals 124. So isn't 4 a divisor of 124? It is, right? So we know that 4 is a divisor of 124. And we also know that 124 is a divisor of x. I'm just using the shorthand notation here, but we're following this exact rule right here. Then we know that A is a divisor of C, so 4 is a divisor of, I'll continue it over here. 4 is a divisor of X, so this is true. Given that 143 divides 1001, is 23,023 divisible by 11? Now this is a harder question, but let's take a look at it. We know that 143 divides 1001, so we can just write that like this. Is 23,023 divisible by 11? So we're asked to see, is this true? 23,023. We can use this same process to find that if 143 is divisible by 1001, what else has to be divisible by 1001? 11, because 11 11 times 13 gives you gives you 143. We know that 11 divides 143, 143 divides 1001. So we know that 11 divides 1001. If 11th, now what about 1001? I know it's going all over the place, but just try to follow along. 1001 times 23 is equal to 23,023. This proves that 1001 divides this, but we know that 11 divides 1001, right? We know that already from right here. From here, now we're given that 1001 divides 23,023. So we can connect these two to say, I'm going all the way to the top here now. 11 divides 23,023. So now 4 is 2 as well. And that's kind of the summary. I know, of course, there are much faster ways to do this. I was just trying to give as thorough an approach, as thorough a solution as I could. So let's quickly recount everything we've learned. Integers are either positive, negative, or zero. Right? We know that. Now, what are the different names? These are natural numbers. Right? We can also call them positive numbers, of course. These are, this is just zero. Right? And these are the negative numbers. These are also called counting numbers. Right? Whole numbers are like both of these. So these are whole numbers. So those are the different terms that we have. We've already done this now. A perfect power is an integer raised to a power c where c is greater than or equal to 2. So an example again is 3 to the second, 7 to the third power, etc. A multiple of an integer is a product of that integer with any integer. And because of this, we know that 0 is a multiple of every integer because any integer times 0 gives you 0. So we know this now. And then the last thing is that if m over n is an integer, m is divisible by n. A proper divisor of a number n is every divisor except itself. So we did the example of 6, right? We know that the divisors are 1, 2, 3, and 6, but 6 does not count. So these are the proper divisors of 6. And n divides m. Yeah, this is just more of the terminology that we went over before. And that's it. That's all we're going to cover in this slideshow. Now feel free to check out the practice problems right below this video. If you want to review the slides yourself, there won't be any annotations in them, but you can just review the slides yourself by scrolling down and opening that up. If you have any questions, feel free to comment on this YouTube video and I'll try to get back to you. Thank you so much for watching. I hope you learned something.